In this video, we're going to look at creating some summary statistics for the green bikes you see around the city of Dayton. So if you remember in another class, I showed you guys how I ended up collecting data using a program to read the HTML directly from the website and find the text that actually lists the number of bikes and the number of docks for every station. So I collected that for a couple days a couple years ago, and I've got a summary file on Isidore for you. So it's called this log 2015-05-19. So if you right click on it, save link as, I'm going to save this to my C drive under CE 221L under bike website. So you can see I already have it here. So you would save it for the first time, and then you can go to the folder. So I'm going to delete the duplicate here. So what we're going to do is we're going to open this up in Excel. We're going to look at some filter table stuff, generate some dynamic charts, and then what I would like to do is generate some summaries using some logic and some range functions, which is pretty useful. So if we open up Excel, do a file open from our computer, we need to go find that file, and the next thing we need to do is actually change the file type to all files. This will allow us to get to this import wizard, and this text file is delimited based on, it modified it when I had opened it up before. So let me delete the original one, go back here, re-download this thing, and let's try this again. So open, so from the C drive, go back to the bike website, open up the log file. There we go. So we're going to go to the delimited format, and it's comma delimited, so every data entry is actually separated by a comma. So this would actually be called a CSV file. I just named it as a log file when I generated the output. So if we look here, we've got a date, a timestamp, a label, a station, and this is usually number of bikes and number of docks. So I'm going to left click over here, and I'm going to insert about 25 rows. And then I'm going to label these headers. So date, time, we'll call this event, station, bikes, and docks. Okay. What we would like to do is actually be able to sort these things based on a date and a time. So one of the ways that the dates are stored is actually in a serial date. So the date is stored as a number since I think January 1st, 1900 maybe, and then time is actually a portion of a day. So if it was 1 o'clock in the morning, that would be 1/24th of a day. If it's noon, that would be 0.5 of a day. So if you put in 12 p.m., it would also equate to 0.5. So what we would like to do here is generate the time, and we're going to do this by taking the value, and let me zoom in a little bit. We're going to take the value of the trimmed version of our time. So trim is actually going to get rid of the leading blank here. There's a space there. And then value is just going to compute it to a numeric number. So you can see here that 6:04 in the morning is 0.25328 points of a day, or percentages of a day here. The next thing we would like to do is actually combine these things. So we're going to create a formula called date time, and it's just going to be equal to my date plus my time. And then we'll copy paste, and then we're going to format this as just general. All right, so this allows us to then sort all of these data points based on the date time stamp. So we combine the date information and the time information, and we just have a floating point number here. Now all of these are the same because they occurred for the same instance of reading the website, but here you can see a different one. This one's about 2 minutes later, and you can actually do a difference between these two things. So you can take a difference, and if we take this and we multiply it by 24 and then we multiply it by 60, that tells you it's 2 minutes. All right. So that was just a quick check. What we're going to do is we're going to left click and then right click insert, and I'm going to cut this, so Control X, and let's paste it over here. So this was just a summary or a temporary value. If we wanted to, we could actually change this to incorporate this. So let me do that just to show you. So instead of referencing the cell, I'm just going to put the thing, the formula right there. So value trim of that cell. And if I turn this back to general, it's going to give me the same exact value. So I'm going to actually delete this column now that we don't need it. We'll copy and paste this all the way down. And now this date time just references the date and the time cell. We don't have an extra cell there, which is a little bit cleaner. The next thing I want to do is look at some filter tables. So I'm going to select all my data, and I'm just holding down Control Shift and the arrow keys to let me quickly select this. Now under the Home tab, if you go to Editing, we can create a filter table. And what this will allow us to do is actually sort things based on the category of information here. All right, so we're going to look at this in just a minute. I'm going to create a scatter chart. So insert charts, we're going to create a scatter chart with straight lines, no data points. And I'm going to right click, select data. I'm going to add a series, and my X data is going to be my date time, and my Y series is going to be this bikes column. And if I look at my chart, it is going to look like complete gibberish, which is fine. We're going to fix this up a little bit. I'm going to change the format of this thing, so I'm going to left click on it, go to format, and I'm going to make it 6.5 inches wide, and I'm going to make it about 4 inches tall. Now the 6.5 comes from a standard Word document with typical margins. So you've got a piece of paper that's 8.5 inches by 11 inches, and you got 1-inch margins on either side. So if you want your figure to fill up the entire space where all your text would be, your figure is going to be 6.5 inches wide, hence the reason I made this 6.5. So we can call this available bikes. We're going to do a bit of formatting here just real quick. We're going to add axis titles, and we're going to change the Y to bikes, and we're going to change the X to date, comma, time, and we'll come back to that in a little bit. I'm going to change the size of all of this to be 10.5, and the title usually doesn't change. It's got some fixed format with respect to that, but I like them all to look the same. Alright, so that looks like a mess. So what we're going to do now is use our filter to update this. So we have our filter table here. I would like to filter first based on the event. So it gives me all possible options here, and you can see we've got an event and a station. So I am going to actually remove all these except for the station. I was doing some output and some calculations in my code to generate this data set, and I would record events, but here we're just going to do it in Excel. So all we want is the raw station data. The next thing we want to do is we want to pick a particular station. So let's pick the Caldwell Street station, which is right at the corner of Brown and Caldwell there. And you can see our chart actually looks a lot cleaner now. So we've got a time series. We need to make sure that it's sorted. So we're going to sort this by, we're going to sort the date time by smallest to largest just to verify that our data points are in line. And now we can change our station and get a summary of the number of bikes. So you can see this is the convention center. We started the day with 4. It jumped up. Some people came by, some people left, some people came by, and so on. So what we could do is we can just pick on these different categories, really only one at a time, because the data would then get cluttered, and we can automatically update these charts. The other thing I'd like to look at is the actual formatting of the x-axis to deal with our date time. So real quick, if we left click on this, it'll bring up, you may have to right click then and go to format axis, but it'll bring up our options over here, and we're going to start wherever they tell us to at the minimum and the maximum, and these are in intervals of half days. We're going to set the major increment to 0.25, and the minor is actually, I need to compute this again, we're going to take 2 out of 24, which is every 2 hours. And that's what we're going to set our minor to. So 0.08333333. All right. Next thing we're going to do is actually add grid lines for the minor vertical axes. And now we want to format our data statements here, or our labels. So if we go back over here and we go to the number, we're going to create a custom style. And the format code is going to look like capital M / DD, which is going to give us the month and the day, comma, and then HH : MM, which is going to give us the hours and the minutes, and these are going to be in 24-hour time. So we'll add that. It's going to be a bit clustered, so we'll go to the size and properties, and we're going to change the angle of this to -45 degrees. So that makes it a little bit more readable. You can see here we started 5:19, and the data started collecting at about 6 in the morning. So here's 5:19 at 6 in the morning. You can see some activity in the early morning. This is for the hospital. And then this is 6 in the evening, and then again around, I'd say this is about 9 or 10 o'clock at night, the activity stops until the next morning. So we can now change this back to Brown Street. We'll deselect all, go to Brown Street, and you can see activity there didn't pick up on that day till about noon, and it was concluded sometime around, what would that be? These are every 2 hours, so sometime around 9 to 10. So this is useful. It gives us a nice way to visualize the data in real time here. But what we may actually want to do is be able to generate statistics based on our data set. And we'd like to be able to take the entire data set and do something to it, and then be able to pull in a new data set whenever we have it and automatically update our table there. So what we're going to do is we're going to come over here to our data set, and I'm going to create a new tab. We'll call this stats. We can rename this one as charts. And I'm going to end up, I think the easiest thing to do would just be to open up, or we can just copy and paste the data again. So I'm going to open up this text file, do a Control-C and a Control-V. This is just another way to get data in. Then go to the Data tab, text to columns, delimited. This is just like the import wizard, and then comma. So here we've got our data set again. I'm just going to add a header to this. So date, time, station, bikes, docks. All right. So what we need to do is actually generate a station list, and the way the data is formatted, we could just grab the first set of data here until it repeats, which would be right here. The other way to do this is just copy it, paste it, and then go to Data, Remove Duplicates. So this comes in handy pretty regularly, and you can actually remove duplicates across multiple columns here. And you can pick which columns you want to consider for duplicates, but we'll just pick this one column, and now you can see we have a list of our stations. So I'm going to move this down a little bit. We'll call this stations. And then what I would like to do is actually eliminate all the events in this data set. So we're going to select it all, go to the Home tab, and we're going to do a custom sort. So we're going to sort by, and this should actually be called type or event. We're going to sort by type, and we'll sort A to Z, and you'll see why. I've got all these events in here. And so let's just go ahead and delete those. So I'm going to right click, delete, and shift all the cells up. Alright, so now my data set only consists of the station data, and we still need to go back and add our date time, so this is good practice. We'll do date time, so this is equal to, zoom in a bit, this is equal to our date plus our value of the trimmed cell for our time. And then it looks weird, but we'll go here and change this to general. And now I've got my data set. Let's sort this using a custom sort again. So custom sort. Let's sort it first by station. And we're going to add a level and sort it by date time. So this will generate a list of all the stations in order for all the timestamps, and then move on to the next station. And this allows us to capture the first set of data here, which is going to be our activity or our change. And so we're going to need to employ some logic to make sure we capture the data accurately. And so what we're going to do is say if the station name equals the cell above, then we can actually consider this. And then if our value equals the value above, then there's really no change. Otherwise, we want to take the difference. So what we're doing is we're comparing the stations to make sure they're the same, and then we are checking the bikes, number of bikes here. And if they are the same, we report this as zero change. Otherwise, we report it at the difference. And I need to add a 0 at the end here. So if they're different, we don't want to consider it as anything, so we'll make it 0. So here we go. If the stations are the same, we do something, otherwise it's 0. So if they're the same, we check to see if the number of bikes is the same, and if it is, it would be 0. Otherwise, we record the difference. And that's just to account for the fact that this first one, you can't really subtract 8 from bikes. So we've got our change, and if we scroll down here, you can see eventually, oh, there we go. We had a change sometime around 11:38. We lost a bike, or actually we gained a bike, so somebody docked a bike there. So you can see our change is recorded as a 1. And then the other reason we had to employ some logic, if I can get to the end of this list, there we go, is when we make the transition from one station to the next, we want to be able to account for that so we don't see this drastic change in our data set. So here is where the station equals station test comes in handy. All right. So what we want to do is actually generate some useful statistics here. I think the first one we want to cover is the number of departures. So a departure would be any of the negative values here where we've lost a number of bikes. And so what we're going to do is we're going to come up here and just call this departures and arrivals. And there are functions that allow us to employ math as well as logic. And the one we're going to look at is sum if. And we're actually going to use multiple criteria here. So that's why we have the sum ifs. So the sum range is going to be the bikes. The sum range is going to be the change, and we're going to lock that. The criteria range 1 is going to be the station, and we'll lock that. And the criteria is whichever station's to the left, and I'm going to make this locked column. Now the second thing is we want to check to make sure our change is negative. So we're going to add another criteria here, and it's going to be the same range over there, and the criteria in parentheses is less than 0, or in quotations, sorry. And what we actually have now is a formula that allows us to sum up the data for this column, the first column, or the first range here, based on a criteria that says that is this range equal to my station name. And then the second criteria is the change less than 0. So this is only going to sum up the negative values, which allows us to get away from summing up positive and negative numbers in the same column. And what we can do is copy that over, and the only change we should have to make is to consider this as greater than 0. So if we copy and paste, what we now have is a summation of the departures and the arrivals. And I don't like how this data is formatted. So let's go ahead and sort it. So sort A to Z. That way we just have these all listed. The stations are listed in a alphabetical order. So that tells us, which station is seeing the most activity, and that's useful. Let's also grab some information up here for the starting date time and the stopping date time. And this is just going to be the min of our date time series and the max of our date time series. And we can also just reference that cell to get a duplicate and format this a little bit different. So we can format that as a time. Let's go to date. Well, let's try this again. Let's go to format cells and let's use a custom format. And we'll just do the same as we used for our chart. So month, backslash, day, comma, hour, colon, minute, colon, second. All right, and if we wanted to, we could compute the total days, total hours. So this would just be the difference between those two. And this would be our total days times 24. So this data set consists of about 2 days, just over 2 days worth of data there. All right, so we've got departures, we've got arrivals. The next thing we might want to do is compute the total activity. And we could just make that the arrivals minus the departures. And this is really just the changes that we're seeing at that particular station. So if you wanted to get an idea of your busiest station, you could sort your list now based off of your activity. So we could come over here and we could do a custom sort based on activity and sort from largest to smallest. So it looks like the Courthouse Square was the busiest, followed by Riverscape, and then the Oregon District, University Place, and so on. So this gives us some pretty good data. We may also want to look at some of the features of our bikes and our open docks. So we might want to compute the average number of bikes available, the max and the min, and this would probably be what type of data that the actual administrators of the bikes would be looking at, because they want to try to balance out the number of bikes versus the number of docks so that they don't have open docks just sitting there being unused. So for this, we're going to use a slightly different type of combination of logic. So I'm going to create 3 columns here that all are related to bikes. So I'm going to select them and go to Home, Alignment, Merge Center, make that bikes, and then we're going to do the same thing for open docks. And then we're going to have an average, a max, and a min, and these are going to be the same for the docks as well. All right, so for the average, there's actually an average if, but we're going to do this a little bit different. So what we're going to do is we're going to use the average formula, and we're going to wrap it with an if that is actually a range. So we're going to take an average of the value here. So the logical test is going to be whether or not the station name locked is equal to our station name over here in our list. And I'm going to lock the column there. And the value of true is just going to be the bikes column. And we'll lock that as well. So I've got average, and then in parentheses if, and this is the station name cells column equals my station name to the left here, and then the value, if that is true, is going to be the number of bikes. So this is going to allow me to average up all of that information. We can't just hit enter. This is a range function, so we need to do Control Shift and enter. So you can see the average number of bikes for the courthouse square was 9.55. And when you look at the formula, you can see these curly brackets around it, which means it's a range function. So I'm going to copy this and paste it to the remaining cells. And I don't really need to see that many decimal places, so we'll come up here to the format and just shrink this down maybe to 1 decimal place there. Same thing for the bikes. I should be able to copy this formula over because I locked most everything, and instead of average, we'll change this to max and Control Shift Enter, and then we'll do the same thing over here but for min. Control Shift Enter. Let's do select copy and paste. And these are going to be whole numbers, so we can get rid of the decimal point there. We can do the same thing but for docs. So we'll open this up, and instead of bikes, we'll switch that over to docs, Control Shift Enter. Move that one over, Control Shift Enter, and lastly min, move that over, Control Shift Enter. And we'll copy and paste. And so what we have, if we zoom out a little bit, is we've got a pretty good summary of our data set. So we've got our stations listed here. We've got the total number of departures, so that's the number of bikes that were checked out of that station. We've got the total number of arrivals, so these are the number of bikes that came back into the station, and then the total activity, which is just the sum of those magnitudes. For the bike column, we've got the average number, the maximum, and the minimum, and then the open docs, we've got the average, max, and minimum. So this would allow us to come in here and decide if any bikes actually needed an increase in the number of stations here or docks, because we may have run out of open docks. You can see that happen one time in the Oregon district, which is kind of unpleasant if you're the one riding the bike, because that means then you have to go find a different station in order to dock that bike. So not very convenient, which means, you know, if that continued to happen on a regular basis, you'd probably want to add stations or docks to that particular station. So this is what I would like you guys to generate for your homework. The first tab, if you remember, we generated a filter table, and we were able to generate this dynamic chart, and from this we can change the number or whichever station we're looking at. So let's go look at that one that was in question here. So the Oregon district ran out of docks. So the Oregon district west, so that's the number of bikes available, and you can see sometime, looks like in the evening, a bunch of people went down to the Oregon district and they parked their bikes, and that means that they ran out of docks. So that's what that really high number there means. So we've got this dynamic chart, and we did some formatting to the axes to make it convenient to copy and paste into a Word document to use as a summary. But we also generated summary statistics here using a set of different functions, all revolving around some sort of criteria. So we use SUMIFS, which is actually a built-in function, and then we went out and we used our own combining average with range functions for the if, and we use those as cell arrays or array functions. So this is a list you could prepare, hand over to somebody, and be able to quickly look through it and get a lot of information. So I think next video I'll show you guys how we can take this particular spreadsheet and be able to just dump in new data starting here. So we'll have to modify our formulas over here a little bit, but then what we'll do is we'll be able to use this again for a new data set, and the data set can be arbitrary in length, and all we have to do is paste our data into the right spot, and that'll essentially make this an updatable spreadsheet so that we could do statistics over a couple days if we wanted to from different data sets, and all we have to do is now copy it into the right spot in our spreadsheet that's already set up.